In this video, we're going to practice using the definition of the derivative. So I've written it over here as a reminder. F prime of A, the derivative of f at the point A, is equal to the limit as h approaches 0 of f of a plus h minus f of a divided by h. Okay, so first example, f of x equals 3 times x. Okay, we're going to look at the point x equals 1. Okay, so x equals 1. What does that mean A equals? Right? A equals 1. A is just equal to some point in this definition, right? So let's plug in A equals 1 to this limit, okay? Wherever we see an A, we're just going to put a 1. So f prime of 1 equals the limit as h approaches 0, f of 1 plus h minus f of 1 divided by h. Okay? This is the limit as h approaches 0. What is f of 1 plus h? Well, f of x is 3 times x. That means f of 1 plus h is 3 times 1 plus h, right? We just plug in 1 plus h where we see an x, okay? So this is f of 1 plus h, which is 3 times 1 plus h, minus f of 1. F of 1 we know is 3, all divided by h. Okay, let's simplify this further. We have the limit as h approaches 0. I'm going to multiply this out. 3 plus 3h minus 3 divided by h. These 3's cancel. So we have the limit as h goes to 0 of 3h divided by h. And these h's cancel. So we're left with the limit as h goes to 0 of 3. 3 doesn't have an h in it, it's just 3. So this limit is equal to 3. So what does that mean? F prime of 1, the derivative at 1, right? That means that we're looking for the slope at x equals 1. Well, the slope of a line is the same at every point, and we know that the slope is 3 because it's the coefficient next to x. So the fact that we got 3 really makes sense, right? This complicated process is just finding the slope of this line. Let's look at a more difficult example. So let's try to find the derivative at 3 different points of the graph x squared, okay? The 3 points that we're looking for are going to be 0, 1, and negative 1. So we're looking for f prime of 0, f prime of 1, and f prime of negative 1. Okay? Let's start out with 0. Okay? So at x equals 0, we're looking for f prime of 0. So what do you think that might be? Do you have any guesses? It's the slope at x equals 0. Think about what the tangent line looks like. The tangent line is going to come in and just kiss the graph at that one point. It looks like that. So this looks like it's going to be 0, right? This line is flat. It has no slope. So let's try to back that up using this definition, okay? So f prime of 0 is the limit as h approaches 0 And then what do? We plug in 0 everywhere we see an a. F of 0 plus h minus f of 0 divided by h. Okay, this is the limit as h approaches 0. Now we plug in 0 plus h. Remember, f of x is x squared, so 0 plus h squared minus f of 0. Well, f of 0 is 0 squared, so that's 0, all divided by h. Okay? This is just going to be h squared. So we're left with the limit as h goes to 0 of h squared minus 0, okay? That's just h squared over h. So that's the limit as h goes to 0 of h. And what's that? What does h approach as it gets closer and closer to 0? That's just 0, right? So what do we find? We found that f prime of 0, the slope of x squared at x equals 0 is equal to 0, which is what we thought, right? This little tangent line clued us into the fact that f prime of 0 was equal to 0. Okay, now let's look at f prime of 1. What do we think f prime of 1 is going to be? Let's say this is x equals 1. Okay, what does the tangent look like? Looks like this. Well, it's hard to say exactly what it will be, but it looks like it's positive. Definitely not 0. Let's go through this same process. F prime of 1. We have the limit as h approaches 0, f of 1 plus h minus f of 1 divided by h. Okay, let's plug in. We have the limit as h approaches 0. F of 1 plus h is going to be 1 plus h quantity squared. Okay? What's f of 1? F of 1 is 1 squared. That's just 1. And all divided by h. Let's simplify. Foiling this out, we get 1 plus 2h plus h squared. We're left with that minus 1 on the right, divided by h. Okay? The 1's cancel, and I can factor an h from the top. So if I factor an h, what am I left with? I'm left with a 2. There's no more an h here, and I'm left with plus h. I took one of the h's away from h squared. Okay? Now these h's cancel, and you're looking at the limit as h approaches 0 of 2 plus h. Nothing happens with the 2, and that h just goes away because it's going to 0. So this limit ends up equaling 2. This really difficult limit, right? What does that tell us? That tells us that f prime of 1, the slope of x squared when x equals 1, is positive 2. Okay? So we knew it was going to be positive. We just didn't know how big it was, what the magnitude was. Could have been 1, could have been 100. Well, turns out it's exactly equal to 2. That's the value of the rise over the run, right at the point x equals 1. Okay? And for the last part, f prime of negative 1. Okay? Let's say this is negative 1. what's the slope going to be here? What's the tangent look like? It's going to look like this, right? Draw that a little closer. Right? What do we think this is? Do we have any guesses? Remember that x squared is symmetric around the y-axis, around the f of x axis. Okay, let's see what it is. F prime of -1. That's the limit as h approaches 0. F of -1 plus h minus f of -1 divided by h. Okay. Plugging in. What's f of -1? F of -1 is -1 quantity squared, all divided by h. Okay, we need to FOIL out the left term. We're going to have -1 squared, that's plus 1. Now we have minus 2h's. We still have a plus h squared. Okay, that comes from FOILing this. Minus -1 quantity squared is positive 1, so minus a positive 1, all divided by h. Okay? Oops. The 1's go away. Oh, sorry, you always need to write, this is a good example, you always need to write, keep writing these limit signs, and I forgot to write the limit sign right here. Okay, so again, the 1's cancel, and I can take an h from the top again. Okay, so I'm left with the limit as h approaches 0. Okay, I took an h from the top. This h is gone, I'm left with -2. 1 less h here, plus h, divided by h. Those cancel. And now we have the limit as h approaches 0 of -2 plus h. Okay, there's no h here, this is just a number. This h is going away, it's going to 0. This limit equals -2. Okay, so the derivative at -1 is -2. It's less than 0, right? That makes sense. Now I had asked if you had a guess for what the derivative was right before I solved this one, right? I talked about the symmetry of the graph. Well, at 1 and -1, you would expect the slopes to be equal in magnitude, but opposite in sign, right? The slope here at x equals 1 is plus 1. The slope here has the same magnitude, it's just in the opposite direction, right? So if you had the slope at x equals 100, then the slope at x equals -100 would have the same magnitude, just the opposite sign. That's due to the symmetry of this graph, okay? So to summarize, we found out that f prime of 0 was 0, f prime of 1 was 2, and f prime of -1 was -2. These values are the derivative of the function at these different points, and they're equal to the slope of the function at those different points. Okay? This is different than just finding the slope of a line, right? The slope of a line is the same everywhere. The slope of the curve changes as x changes, as you can see from the tangent lines, and as you can see from the calculations we did, finding the derivative at the different points.